All right, another Physics Teachers Are Awesome reaction video. I think this is number 103. Can Crush demo. Exciting. Let me make sure the volume is up. All right, here we go.
Hey Tops, so we are getting ready to do a quick demonstration, and hopefully before you read the notes, I want you to complete the discussion regarding this demonstration.
Wow, so much cool stuff already. First of all, look at the safety. Look at the goggles. That's great. Second of all, Dr. Pepper, excellent. Great framing. I think we're going to be able to see everything really, really well. I wonder if I can increase the quality here. No, looks like it's set to auto. Okay. So I think that what I was interested in, the reason why I paused right then was she said, let's really think about this demo before you actually read all the notes. And so I think that people have talked a lot about the ways to have demonstrations like this really impact students and help them really sort of tie some things together. And the idea of, here's something, what the heck do you make of it, before reading how, centuries of physicists have decided to model it. So that's really exciting to me. I wonder how well it works. I mean, students sometimes can't help themselves reading ahead. But no, this looks exciting. So I'm thinking this is going to be a boil the water, get it out, turn it upside down, it'll crush, something like that. Yeah, I'm not sure. There's lots of ways to do this, although I don't think I've done it this way. So let's watch.
And then you can go through the notes, and you're going to actually learn what's happening if you don't already know what's happening. And then you will be able to go back to the discussion, reply to someone, and fix your first response. Or not fix it, but respond again saying what actually happened. So to get things set up, I have a can of water here. So it was Dr. Pepper, but now I've filled it up with just a tiny bit of water.
Cool.
Don't know if you can hear that. It might be.
You can hear it. You can tell that it's a very small amount of water. It's really, really interesting how we know that sound, right? So we would be unable to tell how full it is based on how she's holding it, unless we knew, how much strain she was putting into it or something. But that sound, we already know a lot about how much water is in there, which is not very much. Very interesting.
Be too much, so you're just gonna have to bear with me. We have a Bunsen burner that we're going to get going, and we're going to boil the water in here.
Cool.
And once that gets to a nice boil, I'm going to transfer that into this beaker of cold water. This water, I filled it up this morning, and then I put it in the fridge. So it's been in the fridge for a couple of hours now. So cool. We're just going to hope all of this goes well.
What's interesting about phrases like that, right, is we'll say something like that a lot when we do this in the classroom. But of course, when it's video, we know that she's taken the time to upload this video. So we know something useful is going to happen. Either it's going to be a catastrophic failure and we'll learn something from it, or it's going to work. And so I do think there's a difference between putting these things online versus, and using either your own or someone else's videos versus doing it in front of them. But it's fascinating if you look at things like YouTube, you realize that people post everything. Like, I'm just a one-take wonder here. I almost never, ever, there's no almost to it. I don't do post-processing because I'm lazy, right? I think, well, let's just give it a shot here. Every once in a while I'll say, oh, that didn't work, and I'll start again. But man, even that's pretty rare. You could probably tell. All right, here we go.
I'm turning on the gas. I don't hear any gas. That could be a problem.
See? Exactly what I was talking about.
That's a problem. Okay, it's not going to use gas. We are going to use a hot plate instead. So I'm going to pause this recording and get things back.
So that was really, really interesting, right? So she clearly doesn't mind pausing the recording. We saw that there was a problem with the Bunsen burner. Now, I'm guessing this is going to take a lot longer, although this video only has another minute left or so. So the question is, how long did she pause? Like, did she just do some of the heating up first? Once the video was paused, she could have gone and fixed the gas. So maybe there's some catastrophic gas problem. Let's hope not. So now the question is, did she unpause as soon as she had it set up and we're going to have to watch this whole thing heat up? So it's such an interesting question, right? Once you're going to do things like pausing the video, you don't want to lose track of your train of thought. You want to sort of pick back up with where you were, and unless you do some serious post-processing, you can't go back and listen to yourself and then get it re-queued up. So it's an interesting choice. Let's see what happened.
All right, guys. So I have a new setup. It might be a little difficult to see here, but there's definitely steam coming out of this can.
Okay, so
this is on a hot plate now. And what I'm going to do is I'm going to take the can, and after it steams a little more, and I'm going to place it in the cold water.
So I'm pretty sure the can's going to get crushed because, the video is actually called Can Crush Demo. I'm really intrigued by, she showed the steam coming out, and that was super useful. Notice how she recognized she had to put that little black thing, a mouse pad or something, behind it. The idea, of course, is that the whole can is filled with water vapor. And, I do wonder sometimes about the fluid dynamics inside the can. Could it be that there's a pathway for the steam and that there's, for example, maybe there's some trapped air, like here, right, as opposed to a true chimney that really funnels everything up? Do we tilt it around when we're doing this? I've never done this demo, so I'm not sure, number one, how much of the air you actually have to force out to make this cool effect happen. Number two, whether a chimney would be helpful, or, like a bottle instead of a can, although a bottle is not going to crush. So there's some really interesting things, and my guess is after this can crushes, we're not actually going to be able to know how much air was left in there. I don't think. Because I don't think this bead, for example, gets crushed at all. I think that stays circular. Let's see if I'm right.
So you can definitely see, hopefully this will go nice and smooth. That's why I have my goggles on.
That was awesome.
I also hope this works. But yeah, there's tons of steam coming off. Maybe if I stand right here, you can really see the steam better.
Yeah.
All right.
That's clear.
I don't know if you can hear it, but I can also hear the bubbles. I'm going to go ahead and turn off this heat source. Let's see. And we're going to quickly transfer it over to the cold water.
Here we go.
Woo!
Oh, wow. It happened immediately.
Okay.
Wow, that was fast. It wasn't very loud.
Here's our can now. So that was nice. And
so yeah, you can tell that this shape doesn't get too distorted, and frankly neither does the bottom. It's the sort of weaker part of the can that does it. And so we actually don't know how much air actually went out, but no, that was fast. Honestly, that was faster than I thought it was going to be. And not very loud. Very interesting. Let's go back and see if we can hear it. I'm just going to go back. Okay, so here we go. All right, so now I didn't hear anything. Let's go back now and let's run this slower. Let's run it at that's super slow motion. Maybe that's going to be too slow, but here we go. Oops. Click that button, then click this button.
Over to the cold water.
Nothing's happening. Nothing's happening. Wow! Wow, that's fast. Wow. Okay, that's amazing. All right, let's go back to regular speed here. All right. And hit play.
Woo! Okay. Notice
all the water that goes in it. That's a remarkable amount of water.
That was nice and quick.
Hang on a second. The water goes in. I guess there's no easy way to measure how much water went in. Because if you can measure how much water went in, that will tell you how much volume was displaced, I think, and whether just how much air was left over. Huh, that's interesting. I'm not sure.
Go ahead and in the discussion, just tell me what happened. How did that happen? Ooh, hot. All right.
All right, very, very cool. Loved it. I mean, I just loved so many things about this. I really think that the idea of making sure that she has a video that they can refer to, that they can watch, they can rewind just like we did, as opposed to sitting, 30 feet back in their chairs and just getting one chance to see it. I think there's lots of value there. I think that the troubleshooting she had to do was great. I mean, as soon as she paused the video, all kinds of opportunities open up, because very, very clearly she left the can on the thing long enough to get it boiling before turning, unpausing the video. And so, the flexibility to think about doing that on her feet instead of just starting everything over again, I thought was great. All right, everybody. Well, I thought this was really, really cool. I hope you have a great day. And remember, physics teachers are awesome.